If we are talking about medicine, we shouldn't forget about vaccine. A vaccine is a viral preparation that trains the immune system to recognize and fight against the pathogens without causing the actual disease. So we can also take a great example as COVID-19, a pandemic that shook the whole world. Millions of people were affected and scientists worked day and night to find the solution. The solution was COVID vaccine. For example, Covishield and Covax. When we discuss how vaccine works on people and shows the importance of vaccine nowadays, vaccine is not just a medicine, it's a symbol of hope, science and survival. When you get an injection, a small amount of medicine, which is a chemical solution, is pushed inside your body using a syringe and a needle. The goal is to deliver the drug directly into the bloodstream or tissues so it can act quickly and effectively.
Paracetamol works as a pain reliever and a fever reducer. It contains acetaminophen, which block chemicals that cause pain and fever.
Aspirin works as reducing pain, inflammation and improvement from blood clot. Contains acetylsalicylic acid.
Move and Boily, both are patented ointments used to treat muscle pain and joint pain. In chemistry, diclofenac and methyl salicylate that reduces inflammation by blocking prostaglandin. And menthol creates cooling effect that stimulates nerve endings.
We use fixed develop on day-to-day life for cold, cough and congestion. In chemistry, it contains menthol, camphor and eucalyptus oil, which give cooling and soothing sensation. It simulates nerve receptors and make breathing easy. ORS is used to replace lost salt and water in dehydration. In chemistry, it contains glucose plus NaCl plus KCl. Glucose helps in quick absorption of sodium and water in the intestine.
Antiseptic purpose to kill the growth of germ wound like iodine solution to oxidize the proteins of bacteria. Alcohol dissolve the microbial cells on the microbes. The chemistry behind this is the chemical react to the microbial protein by interacting or killing germs.
The purpose of antacid is to relieve acidity or indigestion. Common chemicals used in antacids like calcium carbonate, which neutralize stomach acid, and magnesium hydroxide, which react with acid to form water and salt. The chemistry behind antacid is neutralization reaction. Bandages and plaques is used to cover wounds, which prevent infection and stop bleeding. The chemistry behind it was some classes have antiseptic coatings like zinc oxide. Zinc oxide contains antibacterial and healing properties. Burn cream and ointment is a semi-solid preparation used for topical application on the skin. It can protect the skin. For example, zinc oxide. The chemistry behind it was zinc oxide ointment reacts with acid or moisture of skin to form a medical layer. We know that many medicines we use today came from plant. Chemists modify these molecules to make them stronger, safer and easier. For example, mustard from Pharmaceutical used as a powerful painkiller. Quinine from cinchona bark used to treat malaria. This is medicinal plants due to chemical extraction medicine company. Hence, we convert these medicinal plants to pills. Sometimes chemicals that are poisonous in large amounts can become life-saving medicines in the right dose. This is what the medicinal chemistry studies. For example, snake venom is very dangerous, but certain enzymes in snake venom are used to develop drugs which help dissolve blood clots in heart attack patients.
There you can see.
This is hibiscus water. So we are mixing vinegar with it and baking soda. So it shows a reaction that poison can be turned into a medicine.
Some medicines are in the form of chewable or gummies. Some medicines are in the form of chewable or gummies. This makes the patients, especially children, feel happier and less scared of the treatment.
We all there in low voice.
Theobromide reacts to same chemical family as caffeine, but it is milder. Theobromide is a purine alcohol found in cocoa, tea and other plants appearing as white.
Firstly, theobromide is used as a form of medicine. Secondly, it supports heart health. Thirdly, it is useful in respiratory problems like asthma and breathing problems, but not used as a common medicine today because others are more effective, but still remains important in chocolate disorders and natural medicine.
Mom, we have a game for you now. She's trying to just a pill. Yeah, mom, you're right. So we are giving you a gift.
See.
Color helps in identifying medicines and make them look attractive. Chemists use safe coloring agents like titanium dioxide, iron oxide and chlorine. Coating also protects the drugs from sunlight and makes it taste better and how fast it works inside our body. This shows this is crushed tablet.
What tablet? Paracetamol?
Yes. And this is iodine solution.
Okay.
it changes color, ma'am. It forms a fluorescent starch.
Okay.
No, we have like
What does it give? Vanilla. Yes. Not pushing up because of sauce. What is the concept behind that? For the ma'am, it's enough. I know. Okay. You're mixing with spindle can.
dissolves in leader, ma'am, but it can be restricted. This is happening due to chemical reaction between pill and can.
Next.
Have you ever wondered how doctors perform surgeries without pain? That's because of anesthesia. Anesthesia is one of the greatest discoveries in medical science. Anesthesia makes us insensitive to pain for a short period of time, making surgeries pain-free. The model here conveys as anesthetic workstation. It's a machine that delivers a proportional mixture of gases and vapor to maintain anesthesia during surgery.
Anesthetic drugs acts on a nerve system, especially the brain and the spinal cord. They block the transmission of nerve signals that carry pain messages. When these chemicals interact with nerve cell membrane, they slow down the movements of ions like sodium and potassium, stopping pain.
One of the interesting and some laughing gas which is used in the modern medical field. Doctors make anesthesia work by carefully choosing the right chemical, giving it a safe dose and constantly monitoring the patient. This chart tells us about the anesthetic doctors and medicine. This chart also tells about the types of anesthesia used in the surgery.
Hemodialysis is a life-saving treatment for kidney failure where a machine cleans the body by removing waste products like urea, creatine, excess water and excess salts. It works by using the chemistry of diffusion and host masses across a semi-permeable membrane.
The main chemistry principle behind this method is diffusion. Waste molecules like urea, creatine, exogases move from blood hydrogen concentration to low concentration.
Excess water in the blood moves across the membrane into the dialysis bioosmosis. Because of the pressure and solid balance, waste molecules move from inside the tube right into the surrounding fluid. Salt imbalance systems osmosis helps in balance water movement.
After some time, the blood inside becomes lighter. This represents clean blood returning to the patient's body. This model shows how hemodialysis.
So it takes all the functioning of pieces. Working model.
Do you know that the ocean are like a giant medicine factory? Scientists have discovered that many marine plants, animals and microorganisms are like chemicals. They are
Scientists extract, purify and analyze these compounds using and spectroscopic methods to study their structure and activities.
So the ocean not only contains fish and coal, it's full of chemistry that can heal us. We must protect our marine life because nature medicine may vanish forever. The chemistry of the ocean truly connects with nature, science and technology.
Every medicine we take must be safe, pure and effective. To ensure this, scientists use analytical techniques. These methods help to detect the amount of active ingredients, impurities and stability of drugs.
Chromatography helps identify substances in the mixture. In medicine, purity and identify compounds. For example, acid-base titration can be used to measure the strength of phosphate. Analytical chemists use such methods to ensure that every batch of medicine has the correct dosage.
Spectroscopy tells us how molecules observe or emitted. UV visible spectroscopy helps find drug concentration. Infrared spectroscopy identifies chemical bonds between the molecules. NMR spectroscopy shows the complete structure of a drug molecule. These techniques help scientists to confirm the identity and purity of the medicine before it reaches the patient. Here is the model of NMR spectroscopy.
Today we are going to explain the chemistry and hand sanitizer. Medicine that protects us from harm. Have you ever wondered what's inside the bottle that keeps our hands germ-free?
The main ingredient in hand sanitizer is ethanol and isopropyl alcohol. Alcohol mixed with the water, glycerol and hydrogen peroxide. Alcohol breaks down into the proteins and lipids which forms the outer layer of the bacteria and the virus. These structures are destroying the germs lose their shape and shape. Sanitizer does not just kill, it chemically kills the germs on other hands. In our demonstration, we will show how to make sanitizer in simple steps. Step 1. Take 70 ml of alcohol in a beaker. Step 2. Add 30 ml of aloe vera gel to the alcohol. Step 3. Pour
course, a few drops of glycerol and 2 to 3 drops of essential oil. Step 4. Stir well using a clean glass rod. Step 5. Pour it into a small clean bottle.
What is that? What's this?
This is a small mix we made in essence.
What is it? Next one.
Have you ever converted to take a medicine? A small medicine dispenser divides that into medicine just like an ATM gives you money. These machines are very useful in hospitals and pharmacies, ensuring that right medicine reaches the right patient at right time. The ATM medicine machine stores different medicines in separate compartments. It uses a computerized system to dispense the exact dose based on the prescription. Many medicines are sensitive to light, temperature, and moisture. The machine controls these conditions to keep the medicine effective.
The machine stores different medicines and uses sensors, timers, and computer programming to track which medicine is needed. These machines are helpful for elderly people or patients.
This technology helps patients take their medicine correctly, on time, and safely. It shows how chemistry and technology work together to improve health.
Medicine making.
Traditional method of making medicine is based on natural chemistry. They provide valuable knowledge for healthcare over centuries, but they are not without significance. Without foreign study and standardized processes, traditional extraction, purification, and the preservation practices face challenges related to contamination and pesticides. It can cause adverse effects if it's taken in large doses.
Today's modern pharmaceuticals still follow the same chemical principles but advanced tools and technologies. Nowadays, medicines look simple, small tablets, and colorful syrups. Modern methods of making medicine be faster, safer, and accurate. Reactions like esterification, oxidation, and reduction to make complex drugs molecules.
Traditional method of making medicine is often based on knowledge and techniques passed down through generation of practitioners. Traditional methods rely on natural observation, while modern chemistry uses innovation analysis and precision. Together they show how science continues to heal the world.
Process of making medicine. The paracetamol solution is added to the first vessel and it is converted to a crystallized paracetamol and it is sent to the dryer where it is used to dry the paracetamol medicine and it is sent to the specimens where binary, coloring agent and screening process is added.
Nice. Well done, children. Yes, that's very good. Thank you.
Good morning, ma'am. Ma'am, it's a great job what you did. Everything I've saw, everything, ma'am. Very nice. Very nice. I have come around, yeah, ma'am. 7:50 I came. Yeah. It's very nice, ma'am. The teacher job and everything very nice, ma'am. Really, very happy about all these things, ma'am. Great job. Yeah, sure. Definitely. Thank you for Everwin, ma'am. Excuse me, ma'am.
The bubbly chemistry behind carbonated beverages. Many people love the refreshing appearance of soda, champagne, beer, or sparkling water. When it takes a sip, the gas will burst and the release gas tickles your nose. But have you ever wondered how carbonation actually works?
Here is some model that will answer all your questions. Let's also enjoy a few fun activities and example of chemistry together. History of beverages, soft drink, open, ready to see CO2 in action. Since the cans are more public than Coke and Mentos experiment, CO2 escapes, soda burn experiment. Bubbles in drinks, coffee chemistry, sugar level in drinks, bubbling milk, coffee, soda chemicals, storing coffee recently, reaching your drink, tooth water. Finally, we come to our Expo with an exciting game that boosts everyone's knowledge.
You know what happens to a bubble when you touch it with your finger?
It does not pop easily. Water prevents Philip from mixing. The first wine for the world was created in China around 7000 BC by fermenting rice and yam fruit. Similar to wine, beef products were also around 7000 BC. The present name is Ethiopia, Iraq. The magic orders were likely the first milk drinkers.
Coffee was already in Ethiopia, Africa, and exported even in 9th century. By late 14th century, people began to use coffee in a different way.
In 1890, soda water was born with a composition of water and sodium bicarbonate, the mixture of acids to form alcohol. Do you know why bubbles are rainbow colored? Because of the light reflecting on them. Carbonated drinks are water and a high pressure expose a large amount of carbon dioxide gas to trigger the lid. When you open the container, the high pressure inside is released and the gas pressure quickly drops to match the normal atmospheric pressure outside.
The lower
pressure make it dissolve carbon dioxide at stable, causing it to rapidly escape the liquid as bubbles. That we can see it as fizz, and here it has popped.
When a soda can blows up a bit or when the can is shaken, the extent has to really to come out. It will open up the can and release the pressure push.
Do you know that bubbles clouded a float or sink?
Vodka says cocktails learn when Mentos are added. Mentos candy is a rough for a surface filled in tiny bugs. Carbon dioxide gas is dissolved in soda under pressure. When Mentos are added, carbon dioxide molecules rapidly form bubbles.
Diet soda is stronger effect because the artificial sweetness reduces surface tension of water. Compared to sugar, this makes it easier for the carbon dioxide to escape the liquid.
As Mentos candies are dropped into the Coke bottle, they receive sudden exploitation second stated and the Mentos Coke fountain goes high up in the sky. Do you know what the bubbles in the boiling water contain?
Water vapor.
Let's see the reaction here.
Carbon dioxide is escaping as gas.
And the bubbles are forming
Due to carbon dioxide.
Okay, makes sense. Well,
Thank you.
but still you can see that.
Very smart. Should gas bubbling because cold temperature increases the solid rate of carbon dioxide gas in the liquid, meaning more carbon dioxide can be dissolved.
When the can is open, the pressure is released, allowing the dissolved gas to escape and form bubbles.
A cold drinking state will be longer because the carbon dioxide escapes more slowly in the cold.
In contrast, a warm can has less dissolved carbon dioxide to begin with, and the gas molecules are more ready to escape, leading to the faster loss of this one. Do you know you can make a bubble that will pop?
And pop up a bubble sounds interesting, right? But yeah, you can make a truly unpoppable one. But add ingredients like glycerin and concentrated bubble solution. You can make the walls of the bubble thicker and better reduce the operation and transfer it along elastic routes. Baking soda and vinegar for experiment works because of the acid-base reaction between baking soda, a base, vinegar, and acid produces carbon dioxide gas.
This reaction creates three new substances: water, a solid called sodium acetate, and carbon dioxide gas.
The carbon dioxide gas is what inflates the balloon because the seal system prevents it from escaping.
Do you know why you can't blow bubbles in space?
You can't blow bubbles in the vacuum of space.
Bubbles need outside air pressure to balance the pressure of the air inside, which is not present in a vacuum. And this is the soda balloon experiment. Here we have added vinegar and baking soda. As a result, we got a product as carbon dioxide. That is the reason the balloon has been inflated. Bubbles in fresh juices are mostly like typical for the yeast fermentation, which produces carbon dioxide gas and it consumes the fruit's natural sugars.
A byproduct of this process is carbon dioxide gas which forms bubbles as it is released.
Over time, other bacteria can also which can make juice use acidic arrangements. Do you know what makes bubbles form?
A bubble forms when something forms like a dry object or a sharp object.
During roasting, complex chemical reactions break down the compounds to the green coffee beans, which creates flavor and generates carbon dioxide as a byproduct. After roasting, a significant amount of carbon dioxide becomes trapped inside the bean structure. They are content to have more trapped gas because the roasting process is more expensive.
When hot water meets freshly ground coffee, it rapidly accelerates the release of this trapped carbon dioxide gas. The rapid escape of carbon dioxide creates a bottling effect on the surface. I have an interesting question. Is it possible to freeze a bubble?
Yes, if the temperature is cold enough, we can freeze the bubble.
Really? Yes. The water in the bubbles freeze and that's how we get a frozen bubble.
Introducing too much air, reducing the passing like that can result in large and uneven bubbles. Fresh coffee beans release carbon dioxide during the brewing and mixing process, which appears as bubbles when we reduce. The air is forced to melt to the bubble to surround the air bubbles, holding them and roasting to create.
Just to get soda, reverse on this prediction with the truth process is more environmental damage and reverse process is not a more
The soda is a carbonated beverage. It's a result of dissolving carbon dioxide gas, which is also the gas produced in the carbonated process.
The soda in a carbonated drink refers to the dissolved carbon dioxide gas that makes it puree. This gas is dissolved in water under pressure.
Coffee beans store CO2 from the roasting process. When finally from coffee is brewed with high pressure, this CO2 is released into tiny drops. These drops are similar to other compounds of coffee, including oil and aromatase. This is caused by different set of compounds including tannins, proteins and other substances.
These components
Be mindful of heated sugars. These are often listed on the ingredients list with the name that end on OSC. Sucrose, fructose, glucose, maltose, and appear early on the list if there is a higher quality.
Rethink Your Drinks is a public health initiative that encourages people to reconsider their beverage choices. They drink rarely. Sodas, energy drinks, and fruit drinks are examples.
Sugary beverages like sodas, energy drinks, and certain other juices contains a large amount of added sugar. Yellow drink occasionally low sugar drinks, diet sodas, and 100% juice.
High consumption of this drink is linked to a chronic health problem. Stop this, go on green. Drink plenty of water. Siphon is full of contains in water containing high levels of dissolved organic matter such as proteins and fats containing antioxidants. These organic substances stabilizing the air bubbles that are trapped by the wave action. This is a close-related phenomenon that can indicate a health in product
Science is everywhere, breathing water around us in the world. Today's quiz is about right answers. It's about thinking deeply and exploring yourself. So get ready to stay.
You have to roll the dice, ma'am, and whichever number appears, if you have a question, if you answer, you will get a reward, ma'am.
It's been almost 15 years since I studied chemistry.
Together, questions, ma'am, actually.
All three, yeah?
Yes, ma'am.
So you will count and they will add up. Yes, ma'am. So 4, 5, 9, 9 plus 3, 12.
What is the theme of this class?
Public chemistry.
Thank
God. You have been. Okay, fine.
Better children.
No, ma'am. Outside we are last row. Forensic chemistry.
Anthropology is the study of human bones which help us to solve crimes or identify unknown people or find out how they died. Chemical analysis of bones can reveal information about poisons, heavy metals and other substances. Potassium permanganate KMNO4 is used to oxidize organic materials and detect certain poisons in bone samples.
Humans contain as 206 bones. Bones can survive 100 or 1000 of years.
Odontology is the scientific study of teeth and their structures. In forensic science, odontology means using teeth, dental records and bite marks to help identify people in criminal cases or disaster investigations.
Teeth are one of the hardest substances in human body. The enamel is made mostly of calcium phosphate, which makes them chemically resistant to fire, acids and decay. That's why even when bones are destroyed, teeth often remain.
Each bite pattern is unique just like a fingerprint. Forensic scientists can match on food or an object to suspect dental impressions.
Age estimation. Teeth can reveal a person's age. Children have milk teeth, teenagers grow permanent teeth, and adults may develop wisdom teeth. Even in older people, chemical changes in the symptom layers of teeth can help estimate age. Teeth serve as better than bones in squares because of the high inorganic mineral content. That's why they are crucial for identifying victims' body.
Eye observation. Forensic experts are careful observation agents tries to collect the useful evidence, which is give importance to the clues about a person, identity of times, dates, and sometimes even cause forensic examination during death.
After a person dies, the people stops to react for the night. The cornea becomes cloudy after some time. The eyeballs may lose pressure and look sunken after some time. The white thin film appears in the eyes in most cases. These changes help the forensic experts to estimate the time and cause of death.
Potassium levels in the white human are tested using the potassium permanganate KMNO4 to estimate the time of death level by celebrating at the brain. Brain observation. The brain is examined during an autopsy to find the cause of death. In cases like head injury, poisoning, or drug overdose, forensic experts carefully remove and observe the brain to look for visible damage and collect samples for chemical testing. Any abnormal color, texture, damage is noted. Samples are collected from car report and help collect the event cause of death. Potassium dichromate detects drug or alcohol effects on the brain tissues. Formaldehyde solution is used to preserve brain tissues for chemical testing.
Heart observation. The heart observation is very important in cases like heart attacks, accidents, or poisoning. During autopsy, they find diseases, injuries, or chemical effects that may have caused death.
The heart is removed and checked for external injuries, blockages, or damage to blood vessels. It is cut open to observe the samples and form. Doctors look for clots, abscess, or abnormal tissues. Blood samples from the heart are also collected for chemical testing. Nitric acid and sulfuric acid used in digestion tests to separate and detect toxic
only portray part in formal observation. Considering such carefully observe and record all the marks, wounds, scars, or patches, or any unusual condition on the skin for additional evidence.
In hydrated ducts, amino acids are spread residues on the skin which turns purple and reacts. Luminous CH7N3O2 detects rest of blood invisible to eyes which emits blue glow under darkness.
Skin observation is a non-invasive, quick and useful method in forensic science.
Starts with the case
Sheena Bora.
Sheena Bora case is one of the India's most highly profile modern investigation solved with the help of forensic chemistry and DNA analysis.
Hydrogen peroxide, H2O2, used to clean and prepare the bone samples, followed by Nirbhaya case.
On December 16, 2012, a young woman Nirbhaya died and attacked by six men on a moving bus. She was injured and died after a few days due to internal injuries. Forensic chemistry plays a key role in proving the crime.
Ethanol is used in toxicology tests to check the alcohol levels of the blood of both accused and criminals. Benzenite is used to check the hidden or the clean blood substance, clean blood stains of clothes, surfaces, and seals. Benzenite is used to is glowed in blue color when it's reacting with iron in blood.
Flame test process is used to identify unknown metal or chemical element in the sample by observing its green color. Calcium chloride gives orange color paint used to test mineral traces in bones or tissues.
And about this sodium chloride. Be careful, okay? What color? Blue color? Blue. Finally it comes, huh? I think it mixes now. This is with oxygen also. Okay, now it should leave it.
In many crime scenes, clothes and personal belongings like kerchief, bags, or jewelry can hold an important clue. They may contain physical evidence such as fiber tears and chemical evidence like blood, soil, gunpowder, or drugs. To examine clothing, scientists use simple but powerful chemical tests. A shirt has red stains and a handkerchief has gunshot residue. When hydrogen peroxide is applied, bubbles appear showing blood. Spraying luminol makes the shirt glow blue, revealing hidden stains.
To detect actual residue, they use these tests with sulfuric acid and a naphtha, and orange spot means residue is present. pH indicators like litmus paper help identify unknown chemical stains. Forensic serology is the detection, identification, classification, and study of various bodily fluids such as blood, saliva, urine, and their relationship to a crime scene. In serology, sero is the Latin word which means the blood or serum. Logy means the study of. Forensic serological tests are divided into two. In that, physical tests like the designated or the luminous test are fixed to see a substance like a bodily fluid next. Confirmatory tests will definitely prove all the substances and are more complex, involving methods like precipitate test to confirm the presence of human blood. This forensic serology is used in simple analysis of crime, advanced techniques, and in DNA profiling. We have collected the blood from the crime scene and we have confirmed that this blood group is O positive. And we have 3 suspects' blood and let us check whether the suspect blood matches with criminals. Suspect number 1. We see that this reaction belongs to A positive and does not match to the criminal's blood. Now, suspect number 2. Here we see that this blood perfectly matches with the criminal's blood, and finally we confirm that this suspect 2 is the criminal. There is another test which is known as presumptive test to find whether the substance we get from criminal scene is blood or any other one.
Here we have collected the blood from the crime scene. Now let us check whether this is truly a blood or any other substance. After few minutes, the color changes into pink. If it changes into pink, we confirm that that is blood. If it does not change into pink, we know if it is colorless like this, we confirm that is not blood and any other substances.
Another type of analysis is called DNA analysis.
Chromatography is used to separate and identify invisible chemicals found in blood, ink, drugs or poison.
Solvents like ethanol, acetone or water mixture are used as a mobile phase to carry out chemicals through paper or column. It makes invisible compounds move and separate. You see that this chemical has been separated into different parts, and scientists analyze this and they will check whether what kind of poison or drugs it is.
According to the color.
If it doesn't change color, there is nothing added in that. You also see that the colors has been changed into
You
different
see the
colors.
parent, Emma? See the parent after this?
Then the inside has been the colors.
Color change.
Something standard.
In ancient Egypt, they used natural chemicals like salt and oil to try and protect the body. The main chemical was neutron, which is the natural mixture of sodium carbonate and sodium bicarbonate, which absorbs all the moisture. In modern laboratories, scientists use the formaldehyde, methanol, phenol, and glycerin. Toxicology is the study of chemicals. Drugs are poisonous to human body. Final substance of poison or
Poisons like arsenic and cyanide and some drugs leave clues in organs like stomach and liver.
Sodium nitrate test detects cyanide in the body. Mercury reagent, formaldehyde plus sulfuric acid. Gives color reaction to drugs like morphine and heroin. Benzenite test detects blood by becoming a blue-green color.
Fingerprint analysis. Fingerprint analysis is the scientific method of identifying and comparing the unique pattern of fingers and lines found on a person's fingertip to verify their identity or link them as evidence in a criminal investigation.
Two people, even the identical twins, doesn't have the same fingerprint. That's why fingerprint is one of the most reliable method of personal identification in forensic investigation.
Nil hydrogen reacts with amino acids in sweat, which forms silver chloride, which turns purple in light. Silver nitrate. Silver nitrate, which forms brownish black film.
Next time. Right. What type of time? The time.
The time.
Or time. Okay. Pattern your family.
How will you see? I'm not able to. It's like loop.
Should be ordered. No, nice. Postmortem.
Autopsy is a careful medical examination of a dead body to find out the cause of death, time of death, and to collect evidence from the criminal investigation.
The doctor carefully checks the outside of the body. They look for injuries, wounds, bruises, bite marks, scars, tattoos or sign of struggle.
Sodium nitrate test detects cyanide in stomach contents. Formaldehyde plus sulfuric acid gives color reactions for drugs like morphine or heroin.
Finally, after examining everything, the forensic doctor prepares an autopsy report. This autopsy report includes the cause and manner of death. For example, whether it was natural, accidental, suicide or homicide.
Children, very intimated.